So today we're going to be studying how to solve non-right triangles, and there's a number of ways to do it. So we're going to start off with the easiest method for solving non-right triangles, and that's to use the law of sines. When you're given angle, side angle, that just means that the side that you're given is in between the two angles that you're given, and angle, angle, side, which means that you have two angles in a row and then a side on one side of those angles. Okay, so our objective today is use the given values, the three pieces of information, a diagram, the law of sines, and a calculator to solve what we call oblique triangles. So we can solve non-right or, one moment, sorry I didn't have my tablet plugged in here, oblique. If they're not right triangles, they're called oblique triangles. If we have three measures, as long as one of those measures is a side. All three measures could be a side, actually, but when that's the case, then we have to go to our calculator to find some values. Anyway, we're going to study how to solve triangles when we're given two angles and one side, so that's our focus for today. If we're given two angles on one side, and there are two ways these angles, these measures can be presented, and that would be in the form of angle, side angle, which would look like this. So I'm just going to sketch a little triangle here. And we're given, say, an angle, and then we're given this measure of this side right here, and then we're given that angle. So you can see what's happening here is the side is included between the two angles. So if this is our situation, we can use the law of sines to solve the triangle. Or the other way is angle, angle, side, where we have a triangle here, where we're given an angle and then we're given another angle and then a side that's on one side of the angle. So this angle here that's in the center of the name, angle, angle, side, is included between an angle measure that we're given and a side that we're given. So if these two situations are presented to you, then you can use the law of sines to solve the triangles. So what is the law of sines? The law of sines says this. Let's label this triangle just the general way that we would name a triangle. So we'll call this triangle ABC. And I'm not going to derive the law of sines right now to explain to you where the formula comes from, but here it goes. This is angle A, and the side opposite it is its related side. That is side A in lowercase. Angle B's opposite side is side B, and angle C's opposite side is side C. So A and A are related, B and B are related, they're pairs, and C, if I were to circle those are related as well. Okay, so here's the two ways you can look at the law of sines. It's just a formula. If you're solving for a side, not an angle, you would want to use this form of the formula where you take the side A over the sine of A. It's equal to the side B over the sine of B, which also equals the side C over the sine of C. And of course, you're only going to do two of these problems at once. You're only going to solve two, like you have A and you have angle C, then you're going to find side C. Then you'll use A and you'll find B and B. Okay, so solving for a side, you want to put the side in the numerator and the angles in the denominator. If you're solving for an angle, then what you want to do is put the angle on the top. So you can just, because these are just ratios and proportions, you can flip them over, sine A over A, sine B over B, and sine of C over C. Okay, so those are just some options there for you. And what we're going to do here is I'm giving you two options when you're doing your assignment today. I'm giving you 8 problems. But if you want to draw the problems with, you say you have your protract, that little toolkit that I had you buy at the beginning of the year, if you want to draw accurate depictions with your tools, then you only have to do 4 problems. And of course, if you don't have the tools, you just solve the 8 problems. Okay, it takes a little time to draw accurate depictions. So what we'll do is solve the problem first, and then I'll show those of you that want to draw the problem. I'll show you how to do that, and those of you that aren't going to draw it, just zip forward or fast forward to the next example. Okay, so this is an angle side angle example. It says in triangle DEF, angle D is 35 degrees, angle E is 48 degrees, and angle F is 7, or side F is 7 units. So here's how I know this is angle side angle, because I have two angles, and it's angle D and angle E, and I have side F, and side F is not a pair of either of these, so I know F is going to be opposite the angle that I'm not given. So F is going to be between angle D and E. So if I have all three letters, it's either going to be angle side angle or side angle side. Anyway, let's draw a picture of it. And I'm not trying to draw an accurate picture right now. This is D. So this will be side D, this will be E, and this will be side E, and this will be F, and this will be side F. And here's what we know. D is 35 degrees, angle E is 48 degrees, and side F is 7 units. Okay, so if I wanted to solve the rest of this triangle, the first thing that I would do is go ahead and solve for angle F, because, well, if I have two angles in a triangle, of course I can do the third angle. So angle F is just going to be the 180 degrees it's inside of a triangle, minus 35 degrees minus 48 degrees. And so I'm just going to go type that in my computer real quick. Let me turn it on here. 180 minus 35 minus 48. And we get 97 degrees. So obviously my picture is not drawn to scale because angle F is not an obtuse angle, but that's going to be 97 degrees. So I'll just grab a different color here and fill that in, 97 degrees. All right, now I'm going to zoom in just a little bit here so you can see a little better what's going on. All right, so now let's find side D. Side D. So we're looking for side D, and we want to use the information where we have two pieces of information. We have the pairs of angle F and side F, and so we will be using those pairs. And let's look for side D. So we go, okay, so to find D, we're going to do D over the sine of D, which was 35 degrees. Let me zoom this over a little bit so we can see letter D there. And that equals F, which is 7, over angle F, which is the sine of 97 degrees. Then we'll just solve for D. Now to do that, just want to clear the fraction over here. We're going to multiply both sides times sine of 35, and I didn't really leave myself a lot of room, so I'm just going to squeeze it in here, and we'll squeeze it in here and cancel that, and so we get D is equal to, and I'm just going to multiply my numerators there and divide by my denominator. So let me get my calculator up, and I'm going to type this in as a fraction. So alpha y equals, and I'm going to do 7 times the sine of 35, and let me be really careful here. I am, notice I'm circling here, in degrees, so I'm in the right mode. If your calculator's in radians, please change it. And then we're going to do over sine of 97, and hit enter. And we'll go ahead and round today's solutions to, let me double check that I didn't do something wrong. That says 4 sine 35. So what I'm just going to do is go up and copy that, and then go back up to the top and change that to a 7. And we'll get the right answer here, which is 4.04. And let's just have you round into the nearest tenth today. So we'll go that that's 4.0 or 4 units long. So that's the value for angle D. Now the last thing we have to do to solve this triangle is just to find side E, and then we're done. So again, we're going to start with side E because that's what we're looking for, and its corresponding angle. So that's the sine of 48 degrees equals, and I would like to stay with the information that I was given in the problem because we did estimate side D. So if we were to use 4 and the sine of 35, then we'd get an estimated answer from our estimated answer. So let's stick with the values that we know are for 100% true all the time. Never work off your intermediate values unless you don't have a choice. Okay, so we're going to multiply both sides times sine 48 and cancel. So times sine 48 and plug that in. So E equals, so I'm just going to come up here, and instead of retyping that, I'm just going to just arrow up to my last problem and paste it. And I'm going to go up to the numerator because I want to do 7 times the sine of 48. So I'm just going to type over the top of that 48. Everything else is the same there. And that equals 5.24. So we're going to say approximately 5.2. So that would be that value there. Now let's just double check and make sure these things make sense. Okay, so my smallest angle is 35. So that should be opposite my shortest side of the triangle, 4. So that's good. My medium angle, or my medium sized angle, is 48, is opposite my medium sized side, which is 5.2, and my biggest angle is opposite my largest side. So just a little way to check to make sure you're on a good track there. So just to double check your work. Okay, so again, if you're not going to try to draw these pictures, I'm telling you tomorrow though, you're going to want to learn how to draw these pictures. The next topic's a little bit tougher, and it'd be nice to know how to draw them. But if you don't have the tools, or you just want to do it mathematically, go ahead and skip to the next example. But what we're going to do here is we're going to draw an accurate depiction. So what I'm going to do is I'm going to go ahead and start with the side. When I'm drawing a picture, I always start with a measure of a side. Okay, so I'm going to get out my ruler here, and we're going to draw 7 units long. So I'm just going to let me get that straightened up here. Okay, I'm going to back this up to 0, and I'm going to take this to 7. You know what, I'm going to double it to 14. So just so that we have a bigger picture. So I'm going to draw the scale at 1 to 2. Okay, and then I'm going to just grab my pencil here and draw, nope, come on, 7 units long. I think I didn't finish that out there. Okay, I'm just going to get that out of the way for now. Then I'm going to grab my protractor. You know what, actually, so I'm going to label this as side F, 7 units long. So what I'm going to do is put angle D over here, which I know is 35 degrees, and angle E over here, which I know is 48 degrees. So now I'm going to grab my protractor, and I'm going to line it up on point D. I'm going to put a little point down here so I can see it, a little point here. All right. All right, so there's 0 degrees here. And what I want to do is open this up 0, 10, 20, 35. There we go. No, 35. It always takes a little bit of time to be precise here. And actually, I'm going to extend this out just a little bit so I can get a nice long line. What we're going to do is just draw a nice line along, make a mark there. If you wanted to with your ruler, you could do that. And then pick up your pencil and draw a straight line there with your ruler. So you make a mark at 35 degrees and then use your ruler. Now I have a really cool tool here, so I can just draw a straight line from there to there. And so I have that angle measure in there. I'm going to get that out of the way. All right, so that was 35 degrees. Okay, so that one's done. And now what I'm going to do is I'm going to go to the other end of this line here, possibly. Well, let me zoom some things around here first. So I'm going to get at the end of that one, and I'm going to start here at 0, and I'm going to go up 48 degrees. So 10, 20, 30, 40, 45, 46, 47, 48. Okay, so that's 48 right here. So I'm going to make a mark. And then I would, move my protractor and get my ruler out and line up point E with that mark there. And then just draw a line across there. And what you want to do is just make sure that your 2 angles intersect. And then that would be angle F. Okay. Oh, and angle E, we'll label that as 48 degrees. Now here's the thing. If I did this properly and I measured these, then this should be a 97 degree angle. This should be approximately 4 units long. And remember, I doubled that. So I'm going to measure it here. I'm going to grab my ruler here and let's see if I can rotate it around. And I'll rotate it around just a little bit. And then I'll go down to 0. And remember that I doubled everything's length. So you can see that I'm here on 8 units. And so if I cut that in half, that would be a length of 4. And then this one was 5.2. E was supposed to be 5.2. So if I measure that with my ruler, it should be 10.4. I'm going to have to move it up out of the way here so I can get cruising around. So 0, and yep, you can see that it ends at about 10.4. That's a little off, but I can't be super precise with these tools. So pretty good. All right, and so that's how you do it. So let's just review that really quickly. What you have to do is start with an angle, a side measure. And then you're going to want the angles that are coming off of each of those ends. And then you're going to draw an accurate picture, and it should back up your math. Okay, there you go. All right, so we're going to move on to our angle side example. So we have here an angle ABC. Angle A is 43, angle B is 57, and side A, this should be lowercase, is 5. So we'll start by drawing a depiction here of angle ABC. So angle A, angle B, angle C. And so this will be side A at 5, and angle A is 43. Opposite side A, and angle B is 57. So what we have to do is find side C, side B, and angle C, side B, and side C. So I would start off by finding angle C, and remember again, that was just 180 minus the 2 angles that I already have. So I'm going to get my calculator out. So 180 minus 43 minus 57, that's 80 degrees. So that's going to be 80 degrees, so I'll fill that in. And then to find side B, we're looking for a side again. So I'm going to, and what I do have, and I was given this information, angle A and side A, that opposite set pair. So we're going to do B over sine 57 equals 5 over sine 43. And then multiply both sides times sine 57 to isolate B times sine 57. And so we get B equals, and we're just multiplying those numerators there. So I'm going to get my calculator here, and alpha y equals, get a fraction. We're going to do 5 sine 57 over sine 43. Double check that I wrote that down exactly right. Okay, so we get 6.14, so we'll just say approximately 6.1. So that would be that value there, and we're just finishing up this triangle. And then we'll do side C. So side C, opposite side of C is the 80-degree angle, so C over sine 80 equals, we'll do again the set of information, angle side pair that we have that was in the given information. We'll use that. Okay, sine 80 and sine 80 on that side, multiplying, and C is equal to, and we'll multiply that together, get my calculator out, go up, copy, paste, because all we have to do is change 57 degrees to 80 degrees. So I'll just retype 80, hit enter, and we get 7.22. So we'll just say about 7.2. And so now we have all the values of that triangle. Now, how do we draw this one? Well, I would suggest again that since we're going to start with side A, which is 5 units, that we're going to draw angle C and angle B off of that value, because it would be very difficult to draw an angle and then a side, because you won't know how long to make the side that's between the two angles that you're drawing. So this is 5 units, but I'm going to go ahead and double that to 10 units long. So I'm just doubling the scale here. There we go. So there we have that as side A. And we're going to say that's 5 units long, and we're just going 5 to 10, or 1 to 2 is what we're doing. We're just doubling the scale there. All right, and then what we'll do is we'll put angle B on this side and angle C on this side. So grabbing my protractor, we'll start on side B there. There we go. And we're going to go, angle B is 57 degrees. So we're going to go 50, 40, 50, 55, 56, 57. There we go. Nope. You can do it. 57. There we go. And then we'll make a mark. And then you pick up your ruler. And you move your protractor and you draw your line. Or I can just draw the line. So I'm going to do that. Super. And then we'll label that 57 degrees. Then we'll come over to angle C here and go back to 0 degrees all the way to 0. And what angle C was 80 degrees. So we're going to go 40, 50, 60, 70, 80. And you see I'm going to have to extend my line here. I'm going to make my protractor a little bit bigger so that I can get a line that goes all the way up there. So make a mark. And then use your ruler to make a straight line between that mark and the end of angle C. And I'm going to have to go back and extend the other side from B. So back to 0, back to 57, and extend that line out until I can get the two angle lines to intersect so I can see where the final point is. And so this up here would be point angle A, which is supposed to be 43 degrees. So I'm going to double check that actually with my protractor now that I put it away. So I'm going to come up here to rotate this around until I have at least one side on 0. So 0, 10, 20, 30, 40, look at that, it's exactly 43 degrees. So it's a perfect depiction there. And so that would be 43 degrees. And then I'll just grab my ruler, and again, remember that side C was 7.2. So when we go to use our ruler, it should be at 14.4. So we'll just zoom it around over here. Maybe. Doesn't want to cooperate. And spin it here. And if you look at that, zoom this out to the end. Pretty close per my picture there, so that's good. And then side B, which was 6.1. So by my calculations, that would be 12.2 units long. So we'll just zip this back around here. Get it at 0. Back this up. And there it is, 12.2. So drawn to scale 1 to 2 is a perfect, accurate depiction of that triangle. And there you go. So your homework today is to do 11.1a. You can do 1 through 8 just using calculations, or if you draw 1 through 4, you draw them and still find their solutions, of course. You can do that in lieu of doing the 8 problems. And there we go.